Hi, today we've got a repair video and in front of us is a Roberts RD70 FM, DAB, DAB+, and Bluetooth radio. Now this was actually only bought a couple of days ago. We bought it from Amazon, but it was an Amazon warehouse product, which means that this was a customer return. Now the description said that it was fully working, just a customer return, and no markings or anything like that on the unit, and it is very, very clean. It looks like it's barely been used. There's a slight amount of scuffing to the display here, but upon receiving it, we actually found that the volume control doesn't work. So this is a rotary encoder on here, and we'll just let it power up. It runs off batteries, it's got an AC adapter, and this may not pick up any signal because the antenna's down. But when we turn the volume knob up and down, it basically does absolutely nothing. Now you can kind of get it working sometimes if you give the knob a good wiggle, which suggests that either the problem is a faulty encoder or a cracked solder joint. So we're going to try and repair this today, and the reason why we're not sending it back is because we actually got this for half price. First of all, it was reduced because it was a warehouse deal. It was reduced to something like £120. Then there was a 20% off for Amazon Prime Day, and then also the AC adapter was broken. It looks like it had been broken during shipping, so we got a bit of extra money off for that. Now if we sent it back and said it wasn't working, all they would do is refund us that money, and they basically said this would just end up in the bin. So it's not worth sending back for a refund, because if we want this item, a new one costs £170, so they're really quite expensive, and this fits perfectly with our theme for the bathroom, which you will see in a future video because I need to get those LED strips finished. So what we're going to do is we're going to try and take this apart. It looks like it should be fairly straightforward in terms of disassembly. So there's 6 screws, some rubber feet, and then we should be able to pull this bottom part out. So I'll just take the batteries out, and then we'll see whether these are adhesive feet. Hopefully they're not. No, they're not. They are kind of feet that are plugged into the hole, so that's quite nice. We don't have to worry about the adhesive there. And then we've got 6 Phillips 2 screws, so I'll get the screwdriver for that. Now this will likely run from an AC adapter in the bathroom. I'm probably going to purchase a medical type from Meanwell. Curiously, the DC input is 7.5 volts, but it actually only takes 4 AA batteries, so that would be the equivalent of about 6 volts nominal. So I'm not sure why the AC adapter is that 7.5 volts. Perhaps it's got a diode or something else in there to prevent it back charging those batteries. So that should be those 6 screws. Let's tip those out. And let's see if we can remove this bottom part. There's not a huge amount to grip onto here. I might have to use a suction cup. There we go. Just being careful of this fake leather, because it does look like it damages quite easily. Right, so we've got the bottom PCB. There's not a huge amount on here really. It looks like there was place for an IC. Perhaps it did support charging on some models, but this one, as soon as you plug in the AC adapter, it bypasses the batteries. So not a lot on that PCB there. We've got a little strange assembly here for the line out and the DC jack that's been all glued in place. It's quite unusual. And then let's have a look inside the radio itself. So there is our PCB at the bottom. We've got these flexible ribbon cables, very reminiscent of old AV equipment, going down to the board at the bottom. We've got a ground plate here for the antenna, and it looks like we've got something like a DAB module or radio receiver module that's then soldered onto the main PCB that controls the LCD and has the rotary encoders and that kind of stuff on there. And then quite a large speaker, a shielded speaker. You can tell by that shield around the magnet on the speaker there. And we've got a couple of baffles and a bass port. So it looks to me like we need to remove the speaker to really gain access to the PCB. And just a quick look there, it looks like some of these parts do slot out from each other. So it looks like there's a plastic piece that actually sits on the front of the radio, and then another plastic piece which, once they've undone a few of these screws, should sort of slot up and then detach from the front. And there we go. So that's the speaker assembly out the way. Quite a nice looking speaker there, as good as you could get for the size. We've got a base port, and then you can see all the slots that allow this to anchor to the front plate. And now we seem to have much better access to the PCB. So I'll move that out of the way. So we need to get to the top side of the PCB. It looks like we're going to have to remove this antenna, and I just see a screw here. I think this should relieve that antenna from the chassis. And yeah, that antenna now will slide out from here. So that's the antenna out the way. So I'm actually going to remove the knobs on the top here next. So we've got two rotary encoders, which I assume, yeah, we just pull those off here. And we've got a couple of nuts holding in the encoders. So let's grab a socket. Looks like a 10mm, let's see. Yeah. Okay, so that's everything from the top that would be holding the PCB in place. Now I think I'm going to leave, you can see there's some screws around the outside for the plastic that forms the top here. I think I'm going to leave that in place and just unscrew the PCB. Now hopefully that doesn't mean we end up with tons of tops of these buttons all over the place that are tricky to get in there. But I think we should be okay. So I'm going to undo the PCB screws next. So the screws are now removed from the PCB, and it should be free to move out, but we've got these cables here which are going to stop us from pulling the PCB out all the way. Now there's two options really. You can see there's a little hook in there holding this coax in place. This is a coax from the radio module going to the antenna, and the shield is connected to this plate at the back, and then we've got another connection from that plate to the ground plane on the PCB. So we could try and loosen this, and maybe there's enough cable then for us to bring the PCB out and work on it. I guess if that doesn't work, then what I'll do is desolder the wire from the PCB and from here and just completely disconnect the PCB, and that will make things a lot easier for the repair and inspection. But first of all, let's just try unfolding this slightly and seeing if we can get the PCB out enough. Right, so we've got that antenna cable free. You can see that's now free to move. That might be enough actually if we lay the radio down. So let's see if we can get this PCB out. Oh, there's quite a lot more on the top side than I was expecting. So on this side of the PCB, we've just got this module, which I thought was just a radio module, but this is actually a full radio SoC. This is a Frontier Smart Technologies Kino 4 SoC, and they've got quite a snazzy looking website. They've got various devices similar to this with this kind of functionality. It's designed for these types of applications, so digital radios, that kind of thing. And it says here it's got everything in there: an RF tuner, baseband, apps processor, audio decoding, and a built-in audio DAC as well. They've got some of the specifications here, but you can see they're recommending it for radios, portable radios, clock radios, that kind of thing. They mention colour and mono because it does actually have an interface for the TFT like we've got on this radio. And if we look at the product brief, the CPU in it is a 360 MHz Meta MTP. Now I'm not aware of this one. This is possibly their design for that. But if we look at the block diagram inside, we've got the RF tuner which does all of the decoding. It's got the baseband in there for RF reception of FM and DAB/DAB+, so all of the codecs as well in there. We've got that CPU, We've got some GPIO for various buttons and that kind of thing, SRAM clock, the audio DAC so that it outputs analog audio, so that in the simplest incarnation, basically you could have this chip plus an audio amp and a speaker and that would be it. Then we've got an interface, I2C or SPI to a display, and then a USB interface. Now I did notice on the bottom of the unit there is actually a USB port, presumably for firmware upgrades. So that's the heart of the unit, very, very straightforward for the rest of the design, because it looks like this basically handles all of the radio features and has the SoC, the CPU, sorry, for doing all of your applications work. And then on the other side of the PCB, we've got all of the other components. And since we're talking about PCBs, probably now's a good chance to talk about our sponsor for this video, PCBWay. So this video is sponsored by PCBWay, who are currently announcing their 8th anniversary of trading. And if you click on the banner on the top of their website, it takes you to their 8th anniversary promotion page, where you can get some free coupons. There's also an anniversary sale, so various discounts on PCBs as well as 3D printing and CNC machining, and you can also take part in a lottery to win some of these items here. And one thing you might not know about PCBWay is they also have a community page, which allows you to share your projects on here for other people to build. Similarly, you can also have a look on here for any projects you like the look of. You can click on that project and order the PCB. And they also encourage the creator to include the bill of materials so the project can be built in its entirety. So don't forget to visit PCBWay if you want to support the electronics community. So it looks like this radio, or at least the PCB, was made in the 38th week of 2020. So we're getting on for a 2-year-old PCB now. And then here we've got a Bluetooth module. So this radio allows you to stream from a Bluetooth mobile device to allow you to output the audio on the speaker here. So this is an ISSC BM20. This is a Bluetooth 4.1 stereo audio module, and basically everything is integrated into this module. We've got the SoC, we've got all the firmware, we've got an antenna here, and what this means is that it's got a UART interface that just allows you to configure the device, tell it when to pair, all of that kind of thing. But once you've paired, it just outputs the stereo audio straight from a couple of pins on here, and you can actually see a couple of these going off to this IC here, which is an ET2354. This is a 4-channel audio processor. 4-channel in that it has 4 stereo inputs and then outputs a single stereo output. So on this radio we've got the Bluetooth module outputting analog audio. We've got the DAB and FM module on the other side of the board outputting analog audio, and there's also a jack on this side for an auxiliary input. So 3 analog inputs going into this IC, and this allows you to switch between those. And then it also has the tone control, loudness, mute, as well as the stereo volume control. And this is just controlled through an I2C interface, which we saw was on that Radio SoC. So nice and easy, suited to this application. We've got a couple of DC to DC converters. It looks like one was associated with the backlight on the display, and one just generally for the stuff on the PCB here. We've also got one linear regulator, one 4000 series logic chip, a couple of op amps, and then we've got the headphone amplifier, which I couldn't find a datasheet for. And one of these is the headphone amplifier, the headphone jack. The other one is the auxiliary input. And then we've got a simple mono amplifier here coming through here, which goes off to the mono speaker. So this is the rotary encoder in question, and the soldering appears to all be fine. So it doesn't look like it's a dry solder joint. We can take a closer look. So looking closer at the PCB, I don't see any issue with the soldering, and the tracers all look fine connecting to that point. Again, the soldering at the top here is fine, although that's for the push button on this encoder, so unrelated anyway. But nothing looks untoward on the soldering on this side. So our encoder signals appear at these 2 vias here. So this is A and B. So A here goes to a pull-up resistor, and then a series resistor off to one of the pins that goes onto the SoC board, and then we've got a capacitor here to ground, and then the same thing for our other signal through a 103 resistor. Then we've got a series resistor off to another pin on the SoC board, as well as a capacitor to ground. Interestingly, we've got a different value resistor, so we've got 4.7k resistor here as opposed to the 1k resistor that is going to the other channel. So I'm not quite sure why they've selected two different values, but these signals all check out fine from that pin on the rotary encoder. So unless something weird is going on with the SoC, I think it looks like we've got a issue with that encoder. However, I will run over these with the soldering iron quickly. Now, I did call up Roberts Radio to see if they would repair this radio before I've done any of this video. However, they won't touch it because it was sold through Amazon Warehouse and you lose your warranty as soon as it's sold on again or second hand. However, I called up Roberts Technical and surprisingly they would provide spare parts. So I was able to get the rotary encoder here, part 1730112, for £1.62, and I think including postage it came to about £4 something. So pretty cheap. It came next day. It's in this box here, although I haven't checked it over. But really nice that any components on the PCB they will supply to the end user to repair themselves. So that's really quite cool. So that gives a bit more confidence that if there are any other issues on this radio, considering it is second-hand, that the warranty shouldn't really be an issue because we can get all of these parts as replacements. So let's have a look and see if that is indeed the correct part that they have shipped. And there we go. So it's a bare encoder, so you do need to keep the lock nut that was holding it into the front panel. But we've got a replacement here, and I did have a quick look before I called up Roberts. There was a close match from what I could see from the outside, guessing at the number of detents and that kind of thing. From Alps, and that was going to cost about £6 from Mauser, so this worked out a lot cheaper. So we should just be able to swap this over, touch up those solder joints just to make sure they're okay, and I think that's it. I'm not going to go any deeper into the PCB because, as I said, if you kind of give the volume knob a good wiggle, you'll get it to work for a couple of minutes. Then if you leave it and then try and do the volume again, it just won't work. So that says it's probably not a software issue or anything else on the board. It does look like it's localized to the mechanics of this encoder. So let's get swapping this out. So we're going to use the Metcal desoldering gun. This is actually compressor powered and it's got a Venturion here to provide the vacuum. So it looks like we're up to temperature, and let's try and remove this part. A bit of heat and vacuum on each of the pads. And there we go. This is a lead-free PCB, so we'll keep it that way, and we'll use our favourite solder, the SAC 405 from SolderKing. And so that's cleaned up the flux residues, and you can see our super shiny solder joints compared to what looks like SAC 305 everywhere else. So that should be a decent repair. Let's put it all back together and see if it works. Now, if you were replacing the antenna on one of these radios, this is the replacement that you would get. You simply undo that screw and it slides out as you saw at the beginning. But when you replace it, you simply just slide it in. Push it straight through, and then you just need to locate it into this cage here and do the screw up. So that's located in there. There's two little metal bits that fit into two slots on the antenna. And then you have a screw and a washer that screw into there. And I'd recommend that you put a little bit of Loctite on just to stop the screw coming undone by itself, because as you wind the antenna up and down, it will at some point twist and start undoing that screw and leave you with a poor connection. Right, and so when I push this knob on, it's probably going to press the button enough to turn it on. So let's see if it works. There we go. So the on-off button works, and there we go. If we twiddle the knob, we get the volume control. So that appears to be a fix. This is the bottom half of the encoder. In the middle, we got the push switch for when you press the knob down, and that's connected to these two sets of contact. Then we've got A, common, and B for the encoder. A connects to here, common to these two, and then B to this set of terminals here. And this pushes against the encoder wheel that's on the top half of the encoder. This is the encoder ring, and basically this is a bit like a PCB. It's got a metal coating on this side with these little sections etched away. And we've got the common terminals which run around this center ring, and the A and B that run around the outside here, and those give us our quadratary encoding. Now there doesn't really appear to be anything wrong from what I can see on this ring, so I'm not really sure why this was failing, and it really was. I mean, it would work for a while and then it would stop and you just couldn't get it to work until you really nudged the volume knob around a little bit. So something was obviously loose or not quite making a good connection. If we look at the actual bottom part here, it does look like potentially the common connections are a little bit more pressed in than the others, but it does still seem to be protruding above where that wheel sits. So I can only imagine really that there was just a slightly poor connection that was stopping it from reading the encoder. So perhaps a slightly unsatisfying repair in that there's no obvious failure of this encoder, but it obviously was the encoder that was causing us the problem. We now have a fully working radio. I managed to get it at a really good price, and also we've saved it from being thrown out, because if anyone else had ordered it and sent it back as faulty, Amazon basically said they would throw it out, because with no warranty with Roberts for a second-hand item, then there's no use for it. So we've saved it from the trash and got a working radio. And it's also really nice that we're able to get component level spare parts from the manufacturer at a really good price, because first of all, if you try and get spare parts from any other supplier, they're not going to give you replacement PCB parts. They're not going to encourage any kind of repair. But also, if they did, they normally mark them up so that it's very expensive to do that repair in the first place. So I've got to commend Roberts Radio for actually providing these parts to me just as an end user. So hopefully you found the video useful. Don't forget to leave a comment in the comment section down below if you've got any thoughts about the video or about this radio. Don't forget to visit our sponsor for this video, PCBWay. And until next time, thanks for watching.